Hey everybody, AVC 10 meteorologist Brenden Mincheff here. We're going to give a quick look at the drought update. Talk about the water situation though, because there's a lot of water in our reservoirs, and believe it or not, there's still snow sitting in the Sierra waiting to melt out. And we're also going to talk about what these stripes here behind me and on my tie, what they represent. Let's get into it though. We'll start with the drought map, and it is pretty much unchanged, although that no drought category continues to tick up just a skosh. A little bit since the last time we did this about 2 weeks ago. 72.32% of the state of California is not in any drought whatsoever. About a quarter of the state, 23.05% in that yellow, that abnormally dry category. Say it every time, but that is technically not drought. That's either recovering from drought or entering into a drought. And obviously in this case, that is all recovering from a drought. And then still the moderate drought, that kind of beige tan color that we see down there in the deserts of Southern California. That is about 4.63% of the state, lowest level drought, and that has been hanging on right at about 4.5% for several weeks at this point. Precip tracker for the month of June in downtown Sacramento, we've seen hardly anything more than a trace. Normally we see about 0.2 of an inch to this point, so obviously we are below average for the month, but still the season as a whole, the water year started October 1st. We are still about 7 inches above where we normally are, and at this point, it's almost a lock that we will finish above average. And maybe we don't see quite as much rain in September, which still is not a whole lot of rain. But at this point, I mean, we're 7 inches to the good in the driest part of the year. We're doing okay with water. All right, taking a look at precip across the state. These are precip totals since October 1st, 2022. And there's a lot of really, really great numbers across the board for the state. Everywhere in blue is above average. Palm Springs just a little bit below, but I mean, if you think about where we were at this time last year, how parched the state was, how badly we needed water in year 3 of really bad drought, these numbers have been a lifesaver and are making for a really great summer with really no water restrictions across the state of California. All right, talking about snowpack, this is maybe the most surprising part for most folks, is there's still snow waiting to melt out of the Sierra. It's not a lot of snow at this point. There's still some up there, but it's not a lot of snow. In the central Sierra and the southern Sierra, it's about a quarter of an average winter's worth of snowfall. So 26% of that April 1st average in the central Sierra, and then 33% in the southern Sierra of that April 1st average. Less in the northern Sierra, as has been the case all winter long. They didn't see quite as much snow up there, so there's not as much snow still sitting in the northern Sierra. These average to date numbers are really, really inflated at this point. I mean, 500% average to date for southern Sierra, but it does tell you that normally we don't have hardly anything still sitting in the Sierra, if we have anything at all. Certainly by this point last year we didn't, but now we do, and this is as of June 23rd. Also, like I said, we got a lot of water in the reservoirs as well. Shasta, Oroville, and Folsom, all at least 95% capacity, but Oroville is at that 100% mark, that triple-digit number that we like to see. And unfortunately, we're going to talk about triple-digit numbers that we don't like to see as much, but we'll get to that in just a second. So as of June 24th, our reservoirs are doing very, very well as well. The month of June maybe has been a little bit of a surprise, honestly, here in Sacramento. 19 of the 24 days so far have come in below average, and only 4 days this month so far have we had a high temperature of 90 degrees or greater. That happened the first weekend of the month on the 3rd and the 4th when we were 93 and 96 degrees respectively. That 96 degrees, by the way, is tied for the warmest day we've had so far this year. The 15th and 16th of June came in at 94 degrees downtown Sacramento, and that's it. That's all the 90s we've had. We've had several days in the 70s, and we've had a lot of days in those really low 80s, which honestly has just made for a really, really nice month of June. Very abnormal and very cool as well. I've run the numbers, and the top 5 warmest months of June we see last June, just last year. 93.2 degrees was that average high temperature. This year, June 2023, 84.3 degrees, that average high temperature as of June 24th. Check that out. That's good enough for 4th on the top 5 coolest list. That is since June 1990. So every June since 1990 through 2023, obviously, has made this list. If we go a lot further back, 1800s, early 1900s, before we had all the climate warming and everything, then we've had a lot cooler Junes. But still, as we look at the climate that is applicable and comparable to where we are today, 2023, to be 4th on the list, just goes to show you how really abnormal this June has been. But it's not going to last that way too much longer. The last time Sacramento made it to 100 degrees was September 9th of 2022. It was 107 degrees. That was coming off of that extreme 115, 116 degree days that we had. So that's made for 288 straight days with a high temperature of less than 100 degrees. Now, the longest such stretch since the year 2000 has been 297 days. We're close to the record. We're within about 10, but unfortunately, it is not going to be broken. That is my forecast. As we look ahead to the 4th of July weekend, can you believe this year's almost half over at this point? So look ahead to the 4th of July weekend, which is next weekend. We've got some triple digits in the forecast. Saturday and Sunday, Sacramento, I do expect we'll see temperatures in the triple digits. Not well in there, but just enough. About 102 Saturday, 100 on Sunday. Of course, that would break the streak should we get there. Monday for July 3rd, about 97 degrees. And then July 4th in Sacramento, 95 degrees. Still hot, but actually that is right about average for this time of year. So like I said, the June that we've had with temperatures in the 70s and mostly low 80s, completely abnormal. Just saw fourth coolest since the year 2000. This is what we would expect to see normally in June and certainly for the month of July. All right, let's talk about the stripes that we started with, right? We're going to show the stripes. This may look pretty, but it actually serves a purpose. It's telling us a story. This is for Earth, the globe as a whole. Blue colors, below average temperatures, cooler than normal years. The red colors that we see on this end are showing above average temperatures. And in the case of the deep red colors that we see right on the very end right here, that would be much above average years. Now, there's no scale on this, but let's put a scale on it now and we can see. So 1860s about where it starts, right at the turn of the Industrial Revolution. And then as we work through the late 1800s into the 1900s, we still see a lot of blue, deep blue in that case, showing that we've had much cooler than average years. But once we get into the middle part of the 20th century, then the colors start to become a lot more white, a lot of that light blue showing near average for that time frame. And then certainly as we get from about 1980 onwards, really the last 40, 50 years, that's when we start to see that warming trend, right? And certainly since the year 2010, we've seen some of the warmest years on record. Now, that's for the globe. We can break this down even more. So here is the stripes for the United States, roughly over the same time frame. Now, we're getting a little more, it's not as big of a picture, right? The globe is a very large place. We see a lot of averaging, a lot of smoothing. Now we're zooming in a little bit, looking at the United States specifically as a country, not North America, but the United States. So now we're getting a little more fine detail, right? So we're going to see more of that variation than we would see when we're taking kind of that look from 30,000 feet. So here's the United States, again, roughly over the same time frame. You do see more of that variation, like I mentioned, but a lot more blue on this end. As we work towards present day, we see a lot more of that red color. And here's that year 2010, and you can see the deeper red colors showing some of the warmest years we've had on record. Notice we've had maybe 1, 2, 3 as we work our way through the 1900s. Certainly as we work through the 1930s, we all know about the Dust Bowl, right? The Great Depression or the drought, right, of the 1930s. It's a big deal. Warm years, dry years, it was abnormal for that climate in that time frame. But we see a lot more red. This is telling us something is changing. Something has been changing in the climate and in terms of the atmosphere and the oceanic interaction. And this is not necessarily a surprise if you know where I'm going with this. Now let's zoom in even more. Here's the state of California specifically. Again, roughly over the same time frame. And it tells the same story. A lot more blue on this end, a lot more red on this end, including some very deep red colors. Now, we'll put a scale on here, and we all know that California has a very variable climate, right? There's a lot of years that have been wetter than average, and a lot of years that have been drier than average, a lot of years hotter, a lot of years cooler, and that's just part of living in California. That's how it's always been here on the West Coast, even before European settlers came over here, even before California was discovered, even before Native Americans were living here in California. You can go way, way back millions of years, and it's always been that way on the West Coast because of how close we are to the Pacific and all of the atmospheric rivers and the crazy weather patterns that can develop from just being that close to the climate, a Mediterranean climate as it's called. But again, just based on the stripes, you can tell something has been changing. There's a story here in the colors. A lot more blue, a lot more red. Yes, there's variation. There's some red over here, there's some blue over here, but you notice a lot more of that red coloring on this end. Let's look at these stripes in a different way. So this is back to the globe, kind of that 30,000 feet view, that big overhead view. All the blue, and look how much blue there is. Look how much more below average we were in the 1800s, even working our way into the 1900s. And then as we start burning more of that fossil fuel, more of that CO2 gets emitted, we see that baseline moving up a little bit. And then certainly over the last about 40, 50 years, now you notice a lot of those reds and just how much taller those red colors are as well. We're going to do the same thing. We're going to look now at the United States, and we'll put a scale on it here so we can see that temperature change and notice how much more below average, again, this is for the United States, how much more below average years we had. Some variation, certainly in the 30s, we saw some of that warmer than average temperature years. But then you notice some more blue as we work through the 50s and 60s. Then once we get to the 70s, 80s, certainly 90s, early 2000s, and then the 2010s, how much hotter we've been. And we really have not had a lot of years that have been at or below average in terms of that 1971 to 2000 average. That's what this is relative to. Same story for California. Here's the California stripes, but shown as bars instead. And again, always has been variation, but notice how much more blue we've got, how much cooler everything has been, and then certainly how much warmer we've been in the 2010s, really even up to just last year. And we can put a scale on this as well, and we'll have that number here, degrees Fahrenheit change. Most of the years before 1950 were about 1 to 2 degrees cooler than average. That's degrees Fahrenheit, cooler than average relative to 1971 to 2000. And then once we work our way into the 2000s and onward, we see temperatures 1, 2, even 3 degrees above average compared to the 1971 to 2000 average. That was for the state of California. And a lot of that has to do with emissions, right? These are anthropogenic climate change. That means it's human-caused climate change. And one of the ways we can see that is by our monthly CO2 concentration. This is ppm, parts per million. And notice over just the last few years how much more that we are seeing in that atmosphere. And this ends in 2021, but I'll tell you, just last month, we were over 420. We set a new all-time high on the Keeling curve, showing how much CO2 is in the atmosphere. And you can see how much it's built up just over the last few years. We'll advance, look at this in kind of a different way. So this is showing us global temperature, which is that white kind of squiggly line goes up and down. There is some variation there. And then that blue line is carbon dioxide emissions in parts per million, right? That concentration. So we go back to 1880, right at the turn of the Industrial Revolution. We're really not emitting any sort of CO2, of methane, of any greenhouse gases. It's just not there. We're not burning it. There's some natural emissions, of course, volcanoes, stuff like that. But you notice a pattern in the CO2, how much it skyrockets. And certainly, once we get to the middle part of the 20th century, and how much it continues to grow as we work towards, on this year, on this chart, the year 2020. And you can see how much the temperature has increased as well. There's very good correlation here between the CO2 emissions increasing and that CO2 concentration increasing and the global average temperature increasing as well. Now, you say there's been natural variation in CO2 for as long as the Earth has been around. That's true. There has been. Absolutely 100% not a lie. But through ice cores and tree rings and some other methods, we can go back about 1 million years. This is 800,000 years ago on the chart and kind of piece together what the atmosphere was like. It's actually really interesting. Ice cores, we can drill into the Antarctic ice sheet, go back hundreds of thousands of years, pull that ice out, and we can actually see a snapshot of the atmosphere during those time frames based on the CO2 bubbles that are in those ice cores. And obviously, as we work towards just the last 100 years, we notice now how much more carbon is in the atmosphere, how much more we are emitting. And these are the data, these are the graphs that we can use to piece together the climate stripes that we've been looking at, right? Why we had so many cooler than average years relative to the 1970, 2000 average, and then all of a sudden everything is much, much warmer than that 1970 to 2000 average just over the last 20, 30 years. Remember the climate stripes, right? So much more red at the end of the spectrum. That's because natural variation has always been around the same levels. Yes, it goes up. Yes, it goes down. But then once we start burning those fossil fuels, emitting carbon dioxide, other greenhouse gases into the atmosphere, you can see now that parts per million is way, way, way above where that natural variation ever was over the last million years. You can go back even further, of course, to the times of the dinosaurs and before that, and maybe you'll find some CO2 emissions that were higher than that because it was higher than that. But over the last 100,000 years, right, when humans have really started to populate and take over the globe, CO2 has never been that high until we started burning those fossil fuels. And that's really important. And we're already seeing some of the impacts of this, not only in heat, but also in drought, right? We can see that changing. Climate changes the atmospheric river systems, the atmospheric river storms that impact California. And so what happens is this is called a bell curve. And this is kind of modeling our climate in a way. So we have some extreme cold events and some extreme warm events, and those fall at the end of the curves, right? Both sides, because they don't really happen that often. Maybe you have one a year, and then you have some warmer than average days, cooler than average days. But for the most part, your average lies right in here. Most of the days of the year are going to fall somewhere right near average. And that's why that curve is tallest there, because that's where the majority of your days are. Fewer days, more days, fewer days, fewer days, fewer days. What happens is our climate has been changing. And so that bell curve moves, it shifts to now more extreme days, right? So if we're comparing the extreme heat days, the warm days, the cool days, and the extreme cold days to that past climate and compare it to the bell curve for our current climate, well, now we have hardly any extreme cold days or years. And now we have even fewer cooler days or years. We have a lot more days in the middle, right? That's why that bell curve is taller there. A lot more days in the middle that are now falling at the higher end of average or even into that warm and now even into that extreme heat days. We're seeing more of those. And so this is a model for what's happening to our climate due to climate change, right? It's not a perfect example, right? But it's kind of a mathematical encompassing example of how we can view our changing averages and how that also changes our extremes. So that's what those climate stripes represent. Now, to tie this back locally, I talked to the Public Policy Institute of California, PPIC. They do a lot of surveys about all kinds of stuff here in California, not all of it environment related, but when they did a statewide survey and they asked what Californians are most worried about. What are you most concerned about? You know, things like crime came up, things like the economy came up, but also things like climate change and the environment came up because Californians, compared to the United States as a whole, Californians want to see climate action. Most are in favor of climate action. It's a super interesting interview. It's all numbers driven. Here's the interview. Here's the story.
This is something that is very popular across most demographic groups and regional groups.
The Public Policy Institute of California, in a February 2023 poll, found 3 in 4 Californians think it is necessary to take steps right away to counter the effects of climate change.
Californians are definitely, when you look compared to the nation, Californians are more supportive, they're more aware, they're more concerned. And that speaks to kind of California being a leader in climate change, which I think Californians also view as important. That California is a leader in the global sense, as well as California can take action separate from the federal government to make policies, and Californians really are supportive of that.
This data comes from a statewide survey about the top issues facing California in general, not just climate change, which shows, perhaps even more strongly, that Californians are concerned.
I'll say that the interesting part about that question is it's asking what's the most important issue facing California today. And so it's an open-ended question. So you can imagine when you're asking about the most important issue, for a lot of people, things like the economy or homelessness or housing availability and prices come to mind. And that's where about half of Californians actually were. Just over half mentioned those 3 issues. And so then you had, government and crime and so it's just one of those things where on the top of mind, it might not be something that really is something that Californians name as the most important issue. But if you look at our environment surveys that we've been doing pretty much every year since 2003, you will find that Californians are very much supportive of climate change policy. There's a wide partisan divide on this question, though, as you might expect, where just 1 in 3 Republicans compared to overwhelming shares of Democrats and independents who say that action need to be taken. I think during that time, probably climate change or global warming or whatever you want to call it, probably wasn't quite as politicized as it is now. And I think, over the last 20 years, we've seen a case where, the parties really have diverged, not only in opinions in our surveys, but kind of in general. We had a Republican governor in 2006, Arnold Schwarzenegger, who was a really strong proponent of climate change and actually was, the governor during some of these early bills that were put in place, like AB 32 and some of the other kind of landmark climate change bills. And that had Republican support at the time. And so I think it's just a politicalization, and now everything is so hyper partisan that climate change is just another issue that has been really politically much more divisive now than it has been in the past.
Former Governor Schwarzenegger continues to be an outspoken proponent of climate action, perhaps now more than ever. It makes sense. He governed over and lives in a state that is seeing the effects of a changing climate. Francis Suarez, mayor of Miami and 2024 Republican presidential hopeful, comes from a city experiencing frequent climate change impacts, and he is also another outspoken proponent of climate action.
And people are now actually seeing links between climate change with some of these weather events.
From more frequent and severe heat waves and droughts to lengthening wildfire seasons and even changing atmospheric rivers, climate change isn't an abstract issue for Californians. It's ever present in our lives. And that seeing is believing mindset is often key to how people perceive the climate crisis, regardless of political ideology.
Whether it's where you live and you're next to a rising sea levels or dam, or even how close you are to industrial areas because of climate change has changed our living patterns, right? And so yeah, it's definitely a big part of the story.